Hi everyone, in this lesson I'm going to go through how to deal with angles that have rotated or over-rotated or under-rotated with our angle measurement. So let's zoom in here. So we have negative rotations is the first thing. So we talked about that the standard rotation is a counterclockwise movement around a circle. But a negative rotation still stays on the positive x. The only difference is that it'll actually rotate in the negative clockwise rotation. So for example, 90 degrees would start at the start the positive x-axis, but go clockwise 90 degrees negative. Okay. Now 265 is a little bit trickier. We know it's really close to 270, but I would rotate that's 90, that's 180, and right as I get to 270, I would be at approximately 265 negative degrees. And then finally, in 390, it's a full rotation, because a full rotation is 360, but I have to overextend by 30 degrees more. And that's what the next part of this lesson is going to talk about. So we have negative rotations is clockwise rotation, but sometimes we have an overextension, or in the case of more difficult angles, how can I find an easier way to describe negative 265? Okay, so let's talk about extra rotations. Now, in a circle, we've talked about how 360 or 2 pi is sort of our main angle rotation, so 360 degrees or 2 pi. But obviously some angles can extend multiple rotations or can just be standard negative. All of the ones that I drew here are negative. But the idea is that we can convert them all into something between positive 0 and 360 or 2 pi degrees. So just because it is not within this sort of boundary of angles doesn't mean it can't be changed into that. So for extra degree rotations, it's actually pretty straightforward. So for example, 1,440, I'm just going to keep adding or subtracting by 360 until I'm between that. So I'm going to keep track of as I do this. So if I minus 360, that's one rotation. I'm going to do it again, minus 360, that's a second rotation. So now 720 minus 360 is a third rotation. Now, since these are exactly the same, it doesn't actually matter that I subtract here or not, because as we've talked about, 0 or 360 is the same rotation. So this could be 3 or 4 full rotations, looking at how many extra degrees there are. Okay, so 375, for example, is a 360 plus 15 degrees more, and we might see that right off the bat, but when we do the subtraction, I get 15 degrees. So what that means is 375 is one full rotation and 15 degrees more. Okay, I'm not normally going to ask you for this, but it's just good to kind of keep track of what that actually means. Now, in terms of negative angles, it's kind of helpful because if I know exactly where negative 120 is, great, but it may be hard for me to see it if it's a kind of a tough angle like 265 was. But if I just add 360 to negative angles, I get positive 240. And so that's its equivalent in positive rotation, and you can see that the meeting point is exactly where we want it to be. So negative 220 is exactly 240. Now this has no full rotations because it never actually exceeded 100 or 360 degrees. Whereas negative 720, if I keep adding 360, I get negative 360. I'm going to add it again. So this is 2 full rotations now. And finally, we can do the same thing with radian measures. The only thing is instead of subtracting 360, we'll be adding or subtracting 2 pi because that's a full rotation. The only thing you have to be very careful of is the fact that we have to do common denominator. So for example, 5 pi, if we even count, that's 2 pi in one full rotation. Another 2 pi gets me to 4 pi, and then I go pi more. So it should make sense that I did 2 full rotations. So then 3 pi minus 2 pi. This leaves me with 1 pi, so I did 2 rotations, and I have pi rads more to go, okay? So this is what we would call that reference angle that we talked about. This is the angle that's basically the same if we just talk about it in terms of the standard rotation. So let's do another one, 13 pi over 2. I'm gonna do my work outside of here so I have enough space. So subtract 2 pi, but again, I need common denominator. So in order to make this over 2, I've got to make my numerator to a 4. And so now I can keep subtracting. So this would be 9 pi over 2. This is still larger than 2. 9 over 2 is still larger than 2, right? That's 4.5, so I have to subtract by 4 pi over 2 again. The good news is once you get the first fraction done, everything else is the same. So I have to subtract by 4 pi over 2 again, and I get 1 pi over 2. So this was 1, 2, 3 rotations, and pi over 2 more. Okay, so in the last two, since it's pi over 4 is my angle there, or my radian measure here, I'm gonna have to keep adding 8 pi over 4, right? Because that's equivalent to 2 pi. So I get negative 11 pi over 4. So let's add another 8 pi over 4. So negative 3 pi over 4. And then one more for good measure gives me the same angle, but just in terms of positive rotation value. That's less than 2 pi. So we can say this is 3. If you want to say negative rotations, you can. A positive rotation and a negative rotation don't really have different meanings. It just tells us the way that it has rotated. But it's 3 full rotations in the clockwise direction and 5 pi over 4 more. Okay, the last one here is meant to be one that you don't actually solve with the method that we just did. It's something that I hope you noticed, is that in every circle is 2 pi rotations. So 2 pi, 4 pi, 6 pi, so on and so forth. And if you notice, 2, 4, 6, the next one would be 8. My pattern is just multiples of 2. So since this is an even number, I can just divide this by 2, which gives me 6,701 pi, or 6,701, rotations. Okay, so if I just divide this by 2 pi, the pi's cancel, and that actually would just tell me the rotation. So the idea behind this is if it's a whole number and it's an even whole number of pi, then it's just whatever the number is divided by 2 rotations. If it's an odd whole number, it has to be a whole number. If it's a fraction, there's a little bit more work that has to be done. But it's that number minus 1 over 2 rotations, and then pi rads more. Let's put degrees there for a second. Okay, so the idea is if this was 13,403 pi, well, it still would be 6,701 rotations, because when you divide it by 2, you get that, and then 0.5, but it'd be that many rotations, and then pi rads more. So you have to keep that extra pi sort of rotating around. Okay, so I hope that was helpful. Thanks, I'll see you in the next one.